In this video, I'm going to solve problems related to graphs of linear motion. Okay, let's start with the first question where we have V against T graph, where it asks you to calculate the acceleration for the three paths and the distance traveled by the train. Before attempting this video, please watch my video on linear motion. Okay, let's start with question A, where we need to write the equation that relate to the question, that is acceleration. So acceleration equal to V minus U over T. Okay, so for part 1, okay, so we have A equal to V minus U over T. So we need to look at the information given in the graph. Okay, where V equal to 8 and U equal to 0 and the time interval is 25. So we get the answer to be 0.32 meter per second. Next, part 2, substitute the information given in the graph and we get 0 meter per second square. This is a constant velocity. And part 3, okay, substitute our V to be 0 and U to be 8 and the time interval to be 20. So we get negative 0.4 meter per second square. This means the train decelerates due to the negative sign. If it's positive, it means the train is accelerating. Let's proceed with question B, where it asks to find the distance traveled by the train. So distance traveled is area under V versus T graph. Okay, so the shape of the graph is trapezium. So we get 1 over 2, 200 plus 245 times with 8. So the distance traveled will be 1780 meter. Next, for second question, we have X versus T graph. So the question asked is to find the average velocity from O to C point and to find instantaneous velocity at T equal to 6 seconds and T equal to 9 seconds. To calculate the average velocity based on the graph, we need to see the final displacement and the initial displacement and the time interval between both points. Okay, so for average velocity, okay, we get the value to be 0. This is because the final and the initial point is the same. Okay. Next, instantaneous velocity is velocity at a specific point. So for this question, it asks to find the velocity at t equal to 6 seconds. So we need to draw a slope that passes through that specific point. So once we draw the slope, we can label 2 points. Okay, so from these 2 points, we can calculate the gradient of the slope. The gradient will equal to the instantaneous velocity for that specific time. So any time that fall between the two coordinates will have the same value of velocity. Okay. So for this one, we get 2 meter per second as the instantaneous velocity at t equal to 6 seconds. Next, we apply the same method to solve the instantaneous velocity at t equal to 9 seconds. So for t equal to 9 seconds, we get the answer to be negative 2.5 meter per second. Okay, let's look at the last question where we have V against T graph. Okay, where we have part A, B, and C. Okay, so question A, it asks to find the instantaneous acceleration at point A, B, and C. So the same method used to calculate the instantaneous velocity can be applied to calculate the instantaneous acceleration, where for point A, we get negative 3 meter per second square, and for point B, we get 1 meter per second square, and for point C, the answer will be 0 meter per second. And the distance traveled, okay, can be calculated by area under the graph. Okay, so we have three parts, so we can find area A, area B, and area C. Okay, so A and B, the shape of the graph is trapezium, so we can apply the equation for trapezium, and for area under the graph for part C, it is a rectangular. Okay, so the final answer for the distance traveled will be 12.5 meters. So that's all. Thank you.